Hello everyone. Welcome to the Highway Survey and Design class. In this lesson, I will introduce the key content of the cross-section chapter. How to draw a standard cross-section design diagram. The cross-section is oriented differently from the plane and vertical profile we learned earlier. A cross-section is a vertical profile along the normal direction of each point on the center line of the road. So, it is perpendicular to the road. The cross-section design diagram is mainly composed of the design line and ground line. In this diagram, the rectangular frame where the letter A is located represents a profile. The shaded trapezoid cut along the normal direction of the highway road is the cross-sectional form at this stake number position. The cross-section highway design includes the following 5 elements. The first 4 items need to be obtained in conjunction with plan views, profile diagrams, and some preliminary data. However, the 5th point requires calculations or the use of earthwork software for transition, providing crucial data for subsequent design and construction. This is the basic data required for cross-section design. You can see that there is a lot of basic information, which is also our preliminary preparation work. In the cross-section design diagram, various sectional information can be observed, such as the stake number information, the cut and fill height, the cut and fill area, whether the subgrade is superelevation and widened, the width of land occupancy, the presence of drainage structures, the gradient of side slopes, the volume of cut and fill, etc. Therefore, we can also use cross-section design drawings to reflect some issues in our design, facilitating iterative modifications and embodying a craftsmanship spirit until the design reaches satisfaction. The first step in drawing a cross-section design is to determine the scale used for this drawing. The commonly used scale is 1 to 200, which means that 1 centimeter on the map represents 2 meters in the actual field. In special circumstances, a scale of 1 to 400 can be used. In the process of drawing, the sequence must not be wrong, from bottom to top, from left to right. Taking this diagram as an example, the stake number at the bottom left is K0 plus 000. As the stake number increases, the layout progresses from bottom to top and from left to right. Step 2. Draw the ground line. The ground line is surveyed on-site. If it is determined on paper, it can be interpolated from a large-scale topographic map. Step 3. Draw the subgrade design line based on the information from the subgrade design table. This step is also called putting on a hat, which involves plotting cross-sections. Along the cross-sectional ground line obtained from measurements at each stake number, the cross-section diagram is drawn by combining the cut and fill height determined by vertical profile design, along with the subgrade width, superelevation and widening values determined by plan design. This process takes into account local topography, geology, and other natural conditions, and refers to the typical cross-section diagram, producing the cross-section drawings for each stake. Step 4. For sections employing retaining walls, slope protection, and other structures, the applied structures should also be depicted on the corresponding cross-section drawings. Step 5. Draw the drainage facilities. Finally, fill in the information such as stake number, cut and fill height, cut and fill area, etc. The cut and fill height can be found in the subgrade design table or the vertical profile design drawing. Cut and fill height is the difference between the design elevation and the ground elevation. Cut is negative and fill is positive. The capital A in the figure represents the initial letter of the area. AT stands for the fill area. and AW represents the cut area. So, how to calculate the cut and fill area? There are 4 commonly used methods for calculating cross-section cut and fill areas, namely the summation method, coordinate method, geometric method, and hybrid method. The shaded area in the diagram represents the corresponding cut area and fill area. Generally, for a fully cut subgrade, the fill area is 0. For a fully filled subgrade, if excavation for drainage facilities is not considered, the cut area is 0. It's worth noting that in a part cut part fill subgrade, there is both a cut area and a fill area. Let's follow the steps and familiarize ourselves with how to draw the cross-section of a straight-line road section. First, determine the position of the point on the ground elevation, and write down the ground elevation. Starting from this point, draw the undulating ground line to the left and right. The ground line is obtained through on-site surveying or interpolation within topographic maps. The design elevation positions are then determined based on the cut and fill heights from the subgrade design table. Subsequently, the left and right subgrade design lines are drawn according to the subgrade design table. As there is no superelevation and widening on the straight road section, the subgrade width in this diagram is 4.5 meters, with 2.25 meters on the left and right sides. The gradient of the road crown is 2%. Therefore, the height difference between the subgrade edge and the center point is 2.25 times 2%, which equals 0.045 meters. If there are protection engineering and drainage facilities, they should be drawn together, ultimately intersecting with the ground line. Finally, fill in the information such as stake number, cut and fill area, cut and fill height, etc. For curved sections of the road, the drawing steps are the same, and the only difference to consider is superelevation and widening. As shown in the diagram, it is evidently a left turn lane. The left carriageway widens from 2.25 meters to 2.85 meters, with the right side elevated and the left side lowered. The superelevation is then calculated based on the turning radius. After completing the cross-section design, these results will ultimately be obtained. Through the above explanation, it is believed that diligence pays off for those with determination. We hope that students will do more practice and be able to skillfully draw cross-section design diagrams for straight and curved road sections. That's all for this lecture. Thank you, everyone.